Oh, what, what a warm welcome. Thank you, guys. How are you? Good? Great. Okay, thanks for the welcome. We're here to talk about ING, what we are doing with stream processing. Probably you've heard the keynote already of Fert yesterday. We're going to pick up from that. So what he basically said was last year was, we were here as well as ING, but we're just gathering data and figuring out what we can do with Flink. And currently we have some use cases in production. Martijn and I will do it together. And even though this conference is all about parallel processing, we're going to do it in serial. So first Martijn, then me. Who am I? I'm Bas. I work at ING. My own background is artificial intelligence, and I've been a data engineer for quite a while, and currently leading the fast data chapter at ING, which is working with Flink, among others, but also systems like Akka and Spark to produce cool features for our customers. And I give it over to Martijn.
Yes. All right, so I'm Martijn. I've been working for ING for the last almost 5 years. My background is in ICT, but I also studied law, and I work officially as a product owner and a data analyst in the business part. So actually, we had a couple of slides about strategy, but I'd like to see some hands who actually were at Fert's keynote, so I can know how fast forward I could get them. Who was at the keynote? Yeah, exactly. That's good to see. So everyone knows most of the slides. So this one, I'm just going to skip over them. This is the important one, developing the analytical skills. It's such a key thing for us because we are in the process of trying to get to the next one, of actually making the shift from batch to real time. So a bank traditionally is a batch-oriented company. We have to be secure and reliable. We want to be omnichannel. We want to be relevant, predictive, actionable, and personal. So those are all things that require us to make that transition. So we're building a streaming analytics platform for high-end capabilities. These are some of the most important things that we have to realize. High performance, low latencies, needs to be scalable, needs to be available all the time, needs to be fault tolerant. And we think that online machine learning and business rules management capabilities are essential for us to function in the end. And from a business perspective, we have some main use cases. One of them is fraud detection, so detection of fraudulent transactions, money laundering. But another one is called actionable insights. So those are more small financial tips, robotized advice, alerting like notifications, chat functionality, marketing, and commercial offering. So those are a couple of the main use cases that we have done for the implementation of the streaming platform. But of course, there are more future scenarios that you can imagine. Wisdom of the crowd, where we actually make use of similar customers for making better predictions, do more with online learning, beyond banking, with Internet of Things devices, robotized advice, advising customers what to do with their finances. Should they, if they have a large amount of money coming in, should they pay off their mortgage? Do they need to start saving, do some investments? Could be anything. But one of the use cases that we actually think is really valuable is insights. And this is what I'm going to talk to you a bit more about. So this is more the business part of what we realize as well with streaming data. So one of the key questions that we have within ING is, do people still need banks or just banking? I mean, the examples are out there. All these major companies are just running platforms and making sure that they add value using all that data that they're getting in there. So we think that whoever is owning the customer experience can actually add customer value or create customer value. And that's something that we want to achieve as well from a business perspective. Because one of the problems, and this is just in the Netherlands, is that our websites, our apps, they are going all the way in terms of design. So this is actually a current representation what is right now in the Netherlands with our open environment, with our transactional closed environment, with our mobile apps. They all look and feel differently. Same actually goes for, if you look at it from a global perspective and you go to the Play Store and you search for ING, this is what you end up with. So these are all mobile apps from all the different countries. Everyone has developed something themselves. And this is something that we don't want to achieve. What we want to achieve is one experience. It needs to feel in sync. It needs to feel personal. It needs to feel relevant. We want to have that omnichannel perfect experience. And what we eventually ended up with is that we needed a formula actually to realize this. So this is one of the key things that we are working for in ING, is that we want to create actionable insights. So instead of just presenting data to the customer, but actually make it insights, make it really personal and relevant for them, and make it in such a way that they can instantly take action on it. And the user interface also needs to know how the customer is behaving, needs to adapt to it. And the intelligence part means that we want to make it feel in sync, needs to be everywhere on the same, needs to be personal, needs to be relevant, and needs to feel in sync for the customer as well. So if you would highlight the main things that we want to achieve with this new environment, is that it needs to be everywhere. It needs to be personalized. We want it to make actionable. And one of the things from a user experience perspective is that we based it on the material design that Google has done. So if you look at it from an actionable insights perspective or an insights perspective, what actually was that we designated some zones in the new environment where we want to have that personal and relevant communication with our customers. So, for example, at the top, that's so in your face for the customer, it needs to be absolutely spot on, and it needs to be content where if the customer doesn't act on it right now, he's worse off. So that's one of the rules that we have for the top one. But you could also do some more other zones where you have different types of rules for different types of content. And right now, I'm going to focus on the one on the top because I think that's one of the most important ones, and how we actually decide, okay, what type of alerts or notifications, insights do we want to present there. And they all start basically like this. So this is basically an idea. So imagine yourself, hey, it's Friday, I'm having a beer, buying another round, and then you get an instant notification on your app, and it says, hey, you've made a recurring planned transaction, which normally would happen tomorrow, but your balance is now at such a low level that tomorrow that planned payment will not succeed. And what then the notification allows you to do is you click on it, you open it, you get the message on your screen, and you're like, oh, fuck, this is not going to work. So you click on it, you go to the actual money transfer, where you can get some money from your savings account, which is pre-filled with the amount that you actually need. You push the button, you authorize the transaction, and it's done. And you can go back for another route. And this is something that we actually built from a real traditional ING batch implementation. It looked like this. So imagine you have a lot of stuff in our data warehouse. So we know, for example, customers that are currently in overdraft, so who don't have enough funds on their payment account, but they might have enough money on their savings account. So what we do is we grab those customers just using regular SQL, grab those information, those customers from the database, and we store it somewhere. And we build a nice looking front end. I'm going to show you a bit better right now. It's on the right. So imagine that you're coming in, you're logging in on our digital platform. And what happens is that actually we have an API. It's getting that result from our cache table, basically, from the result from the SQL. And then what we do is that we real-time validate with our system of records if the situation is actually still applicable. And if it's not, then we don't show anything. But if it's still the case, we can actually show it. So this is something that we actually put into production. And if you would look at it, I have a movie about this. This is something where the customer actually has not enough money on his payment account. It's €5.47. And that's something that we are saying to the customer, hey, if you click here, you can solve this situation. There's also two other options in this specific front end. One is for snoozing, and one is for rejecting. So you can hit the snooze button, which means that we won't bother you with this insight right now, but we'll probably use it for an hour or so, we will show it again. Or you can just say, no, I'm going to reject it, I don't like it. But I'm not actually sure if it already went through. Yeah, so if you actually hit the button, yes, I want to transfer all those funds, you see that everything gets pre-filled. So you get the orange savings account, you get the amount that you actually need to solve your overdraft situation. You only have to authorize it and then you're done. That's how quick and easy and actionable we want to make this happen. But there are so many options that we can do with this. But in order to actually make real added value, we would really would have liked those real-time capabilities that our streaming platform should offer.
Thanks. Yeah, so you know what happens when the product owner looks like this, right? Then the engineers better get to work, and quickly, because then things will start happening. This doesn't work anymore?
No.
Okay. All right, so I'm going to tell you a little bit about what we did, how we built this platform. We call it the streaming data platform, very originally, of course, which actually, of course, should be able to cater for all the different use cases that Martijn just mentioned: fraud detection, actionable insights, and maybe others to come in the future. So before we actually started this work, we gathered some input and we thought about it carefully. And one of the things that we actually noticed, that if you really want to build such a platform with a lot of data available and a lot of actionable insight for many different customers, you should actually build a system which is probabilistic in nature. And what does that mean? Streaming data processing, you can always do it, of course, with a set of determined rules. So if you basically ordinary program Flink and you define your code, then it's deterministic. That the other end of the spectrum. Deterministic software has given a set of input, has the same output all the time that you put data against it. But if you want to make predictions, or if you want to be busy with things like the customer relevancy, then all those things are not really easy to capture in rules. You have to do stuff with machine learning or with fuzzy logic. And that's where the probabilistic nature comes in that we had to build into the system. So I'll tell you a little bit how we did that. But the arrow, the blue arrow is not entirely on the right side because, of course, we work in a bank. So we always have a little bit of deterministic data processing going on because there's rules we have to comply to, and there's certain things that you say, okay, if we give a customer, for example, an insight, or if we're going to predict fraud, then we leave it up to an algorithm, to a neural network, for example, to decide what's really going on. But it all has to be within certain boundaries, within certain constraints. So that's why we had to make a combination of these two sets of ways of building a system. This picture you already saw yesterday as well. This is the general architecture that we built. Basically, what we did is we built a data pipeline. So another pattern that we are using is pipes and filters pattern, maybe common in architecture if you're aware of that, where data flows in from left to right all the time. And we designed a system which is always Kafka in, Kafka out. So the streaming data processing platform that you see on the top that's what the rest of my talk is going to be about. And specifically the Flink part, of course. You see the rules engine that we still have there, which is a SAS component, which is also possible to be used at ING currently if you only want to do some simple rules processing. So there could be use cases that we say, okay, we don't need all this complexity of Flink and machine learning and et cetera. We just want a business user to have a graphical interface to write up their own rules. That's perfectly fine. They can use SAS for that as well. But not so interesting for now. A little step deeper, if I look into the Flink architecture that we set up for this, is this pattern that we are following. Basically, we split up our data pipeline in 3 major steps. One is the raw to relevance component, one is the model execution component, and one is the post-processor. Post-processor is the least interesting, because it's just a formatting step. So once we determined a relevant action for a customer, an actionable insight, or we determined, okay, we're going to send an alert for a possible fraudulent case, then we have to format it in a certain way. That's what the last component is doing. But the other 2 are where the actual logic is taking place. And you have to imagine that at a bank, at ING, a lot of data is being streamed. So we have lots of event-based data. And to name a few, the few most important ones are, for example, transactions. People, we have millions of customers who generate billions of transaction events every day, and it only gets more because they're for example, in the Internet of Things and in all kinds of new ways of interacting with the bank. The transactions get smaller and more. So microtransactions are actually what is coming next. But one of those points, one of those transactions, it doesn't really mean something, right? It means like customer A is transferring 10 euros to customer B, or it has the meaning that one customer is getting 100 euros out of an ATM somewhere around the world. Of course, you can maybe act on that, but usually you don't want that. You want to act upon combinations of those kind of events. And that's what we do in the first step. We call it raw to relevance. So the raw data is all the raw action points, and we want to make that into a useful piece of information, which is relevant to be able to act upon. You could call it also other things. You could call it complex event processing, or filtering, or aggregating. That's all the basic stuff that's happening in that component. Once we have that, so once we signal something. For example, we signal that somebody is running out of money, or we signal that there is something happening on in the stock market. There's also not a data that we can analyze, the stock exchange, or the mouse clicks of people, the URLs that they visit. Once we see something interesting happening there, the next step comes in, and that's actually to determine what we're going to do with that, and that's where the machine learning comes in, because then we say, okay, this piece of information can lead to certain actions based on this type of customer, for example. Because remember, it has to be personal and relevant. So what happens in a certain situation with me as a customer can be entirely different than somebody else. So to get to that step, you can look at the small blocks in the overview, what we're doing there. First, we should enrich the data that we get, the interesting information, with the customer profile. That gives us more information to actually use in scoring a predictive model that says what is relevant for a customer at that moment in time. So in terms of machine learning, if you are a data scientist, what you do is you actually going to extract features from the combination of event data and customer data. That's your feature set, and you give it to a model to give you a prediction for a certain relevancy of a notification. And I have some examples of that. So, first example is it's fraud detection. So imagine we have a point in time, transactions coming in, and this is one customer who is getting money from an ATM. So at 9:14 he gets 150 euros somewhere in Amsterdam, okay? At 10:10 he gets another 100 euros from another ATM in Amsterdam, okay, sure. But at 10:12 he gets another 100 euros in Berlin. And that's an example of points in time which are independently of each other perfectly fine. People just get money. But in this series, there might be something tricky going on, because how can I get from Amsterdam to Berlin in less than 5 minutes? That's physically impossible, unless I maybe have a magic carpet that flies extremely fast. So that's why we call it the magic carpet syndrome. So the first step is to detect this pattern, which we call the magic carpet, and we do it by in Flink we do it with a sliding window, where the window trigger is always a transaction for a customer. So if a customer takes a transaction, then we always look backwards in time, saying, okay, if the next transaction is physically possible, okay, all fine. If it's not, it could be fraud, or it could be that there's a technical mistake, of course. It can be anything that is not good, at least. The next step is that we actually want to predict, at this moment, in real time, this could be a fraudulent transaction. And then the next model comes in. That's the step, what are we going to do with this? So in this point, we've lost all the raw data. We gathered, aggregated this data into an interesting business event, what we call it, an interesting event, which is, hey, there's something wrong, there's something not right here. This is physically not possible. But then again, that can lead to multiple actions. We can do nothing because maybe we already know that this is test case, or this has happened before and it was okay, or whatever. Or we can maybe say, okay, this is really not right. We stop the money flow. Or we even know, hey, this customer is doing other stuff which has also been a bit shady. We're going to block this whole account for some reason. And maybe there's of course a huge list of actions that we can take. Then we throw what I explained before. We throw this data, this combined event data with the customer data. We give it to a model. In this case, the model to predict which of these possible actions is the most relevant, and there comes out a score. And a score is always a value from 0 to 1, where 1 is the highest and the most likely scenario for this person in this situation. So the model lives in the Flink cluster. We give it the data. In this case, you see that option 2 gets the highest score, 0.91. So that's the one where we're going to continue, and we are going to block the transaction. Okay, of course I have to add some code examples here. So how do we do this in Flink? And this is not actual ING code, as you can see, because so Gijs, don't worry, it's it's covered. But what's nice is that if you think about this kind of steps in a general way, you can also generalize your logic. So if you think, hey, what kind of code is this? Is this not Java, not Scala, not even something I'm familiar with? That's true. We wrote our own DSL to be able to adjust the Flink operators in real time while the Flink jobs keep on running. And that's so the DSL is what we can push into the to the Kafka stream and into the Flink jobs there to be able to make this kind of predictions. And what you can see in the DSL, I'm not going to go through all the details about this, but it's, for example, calling a function here, PMML predict, and it's calling a PMML file. I'll get to that later as well a little bit, which is basically the model, the machine learning model that gives the prediction for this scenario. Okay, another example. Again, transactions, right? People spending money all the time. We have billions of them every day. We can do interesting things with them. We can do fraud detection, but we can also help customers with their financial situation. Wouldn't that be nice? That if we see something happening, that we can give customers a little piece of advice or a suggestion what they could do, based on things that they've done before or things that they told us that they would like us to do. So let's see if we can help this customer in that way. But this is a customer who's just spending money, right? In one location, let's assume he's in Amsterdam or she's in Amsterdam. At some time points, there's money going off from his bank account. Again, one of those events doesn't lead to anything, but the combination of those events could lead to something interesting. And in this case, we defined again a sliding window, looking backward 1 hour in time, and it will be triggered by the customer balance reaching below 400 euros. Because in that case, if we see multiple transactions and we draw the line further down, we could predict that there's something happening that might cause the customer to lose money, so that he doesn't have enough money for his next purchase. And that's of course not nice. Then he will be in a shop wanting to buy something and he's running out of money. The balance is 0. So again, same pattern. The pattern that we did, the same process, the pattern that we detect is, hey, this customer might be shopping. Again, that doesn't lead to anything yet. But the pattern detection that we apply, we can predict that in the next few hours, or in this case at exactly 4:11, the balance of this customer will reach 0. Okay, and that we can see that coming already. So again, based on this personal situation based on his customer profile combined with event data that we have a few options for this person. We can again do nothing. We can maybe send a WhatsApp message, or maybe inform her husband. You know, like your wife is shopping again, for example. I would like that to happen. Or we could maybe say, we can give you a push notification with a little suggestion. Hey, we noticed that you might be running out of money. Why don't you transfer? Do you want us to transfer some money from your savings account? Because we noticed that you still have a few €100 on your savings account, and then you can cover for your next purchase. Again, same pattern. We score all these possible actions for the customer. We give them a score. In this case, the highest score is 0.57, which is above a certain threshold. So we send out this notification to the customer, and it's personal, it's relevant, it's actionable, and based on like in the video Martijn showed, people can accept it or ignore it or do with it what they want. Okay, last example is an interesting one. Again, this is something we built for our customers who are doing something online. So another scenario where our events are page visits. So you imagine that a customer logs into the ING website and he is interested in something. It could be a mortgage, it could be a loan, and to request something like that, to request, for example, a loan, that usually takes filling in some forms and taking some steps on the website. And let's assume this loan that a customer wants consists of 4 steps, 4 forms that he has to fill in. Then the usual pattern is, of course, that those 4 steps will be followed and completed within, let's say, one hour or half an hour. But if we notice that a customer blocks or is stopping at page 3 and is not actually completing page 4 or not visiting page 4, there might be something wrong. He might get stuck, he might not know what to do, he might miss some information. So again, real-time scenario in that sense, or not really real-time, but maybe like after waiting 15 minutes, we could give him a notification. So in this sense, the pattern is that we detect that the customer is interested in a loan because he's visiting some certain URLs. We predict actually that the customer is blocked somewhere because the 4th page is not been visited. There's again some options that we can do, and in this case we score it and we actually going to give him a call. We're going to give him a call saying, hey, we noticed that you completed 3 of the 4 steps. Are you no longer interested? Can we help you another way? Proactive advice, again, that really helps our customers. And the way that we actually build this kind of stuff is with the library Flink CEP. Maybe you've heard it, but this is another nice example of how you can use a native Flink library, Flink CEP, to detect these kind of patterns. And the nice thing about this, what I really like, is that you can, this is really perfectly readable. Even if you're a business user or not really into things like Scala or Flink, with all the complex things like event time and windowing and save pointing, check pointing, whatever, you can still program this and you can read it because we just defined some steps here, and there's 4 pages. We assume that the steps follow each other, and that the step 3 follows step 4 until at some moment there is a window of 15 minutes. Where is that defined? Well, I'll see that here. Where actually we're going to say, okay, we have a timeout pattern. We have timeout for this kind of pattern. So we're actually going to signal something as a business event. More architecture. You've seen all the top stuff already. That's the functionality. You already know we do Kafka in, Kafka out. You already know some libraries that we use. So I'm not going to explain everything like that. You already know that we have the option for a DSL, which is injected into a control stream, again, through Kafka, to adjust the behavior of this Flink operator on the fly. And interesting thing is that, of course, we have to work together with data scientists who produce the actual models. And they have their own environment to do that, and they can basically work with any tool they like, as long as they produce some kind of PMML output, which we can then load again into our model execution engine. And finally, of course, the customers who receive a notification, which is actionable, which can be used to say, okay, hey, ING gives me a suggestion, I like it, I'm going to do it, I'm going to transfer money from my savings account, or I'm not going to do it, or I'm going to ignore it, or I'm going to snooze it. All that kind of feedback is, of course, important for us to be able to retrain the models again for these customers. Because then we know, hey, this customer is interested in this kind of notification that we sent. This customer is not. This customer in this situation might be, receptible for this advice, and might be not. So this feedback loop is now, basically what we do manually. We gather all the data and we retrain the models with that. But in the future, we really want to get that as a automatic feedback loop, where you actually could update your models on time. Then you will actually have a real, autonomous system that is really retraining itself all the time. So the combination of offline training and online scoring, this is. Okay, why Flink? Basically, this is the question I get a lot. You know all the good stuff, right? Flink has really good capabilities, through streaming, per event processing. It's high volume, low latency, so it's extremely fast. And actually, it fits our culture. Like Vert yesterday explained, we want to be an engineering company with a banking license. So although some tools are still valuable to us, like SAS or IBM products or whatever, if we really want to build a streaming platform for the ING global, for any use case, with any teams working on it, then we actually should be aiming for using open source technology as much as possible. And we thought Flink was the best choice in this. We actually also did an experiment to prove it, because it was not that we gave our board this slide and said, this is what we're going to do. No, we set up an experiment to really prove that Flink is the right choice for this, for the next years to come. And we did performance testing, for example. So this is some of the results that we really get out of this. We tested some scenarios in the actionable insights atmosphere, for example, giving customers a suggestion to transfer some money, what I just explained previously. And we got some really good test results out of that, where we got on relatively simple testing hardware, we got a throughput of almost 500,000 events per second, with an average latency of under 50 milliseconds. So we really proved that, even if we throw a lot of data against this system, we can probably cater for only one Flink cluster, which is just running in production. And we also proved the scalability of the Flink system. Why PMML? Well, because we had to find a way to make the cooperation between data scientists and data engineers as easy as possible. There are probably other systems who can do more fancy data scientist work. For example, you have systems like H2O.ai, really specialized in machine learning. But for a starter, we said, okay, let's focus on an interoperability format, which is like standardized in the market, and which is easy to use in a Flink context. It turned out that PMML is currently, the de facto standard for that. It's an XML exchange format, if you're not aware of that, which represents a machine learning model, or it can also be a simple business rule in XML code. It has limitations because it doesn't because if you, for example, have a very big model, a very complex neural network or a random forest, it will lead to a big XML file. So actually, you should be a bit careful of how you are using this format. But so far, we've seen that all the models that we're running are pretty well covered in this format. And there's standard Java libraries that you can use in any JVM-based system, which of course Flink is, to score these models. And we use OpenScoring.io for this. Also, I'm involved in an initiative with people from Lightband and RadicalBit to try to open source and to make this a more generic approach in the Flink ML library. There was yesterday a presentation about it as well. So we actually want to make this available for everybody. And yeah, so again, next the tools that we can say to data science to use are a lot of tools as long as the output is PML. So you have to click on the export button, export to PML. How does it look like? This is an example of a PML file. Not going to details about this as well, but you actually can actually read it. That's also a nice feature about this. You can actually see, okay, this model requires this kind of features with this kind of data types, and it does this kind of type of calculation. This case, there's a logistic regression model which takes some customer features, like his age, and some calculated real-time features, for example, his monthly balance, the average amount of money that he spent in the last month. We also chose Flink because it fits nicely in our way of working. ING is an agile company where we have an operating model that is that really caters for multidisciplinary teams, where we have developers, operations, data scientists, etc., working in one team. So again, PML helps with that as well. But also, it turns out that Flink, since it is a Java library, it runs on basic hardware. It has a relatively simple deployment model, both for the middleware and for the jobs themselves. So we can actually incorporate it quite easily into our continuous delivery pipeline. So, and we proved this as well. And it's actually easier than with a lot of vendor tools that we also tried and looked at. And this really fit the culture of ING in that sense. And this is a picture about our way of working. Maybe you've seen it before. It's what I also already explained before. We have squads where actually people from business and IT are combined into one and build one purpose functionality for the bank. So in this case, we can say we built a platform based on Flink. It's up and running. It's nicely zooming on the background. Hey, we have a team which wants to use that. For example, they have a streaming use case. They want to give a certain type of actionable insight to a customer. Okay, go ahead. Here's the tools that you can use for that. And you have your own people, you have your engineers and your business people who can really make that happen. You're not longer dependent on the platform team, or you're not dependent on an operational department who has to maintain it for you. You can take it on yourself as a squad, and you can utilize the platform to make to really make your purpose come true. Okay, I think we're running out of time, or not? Okay. At least on my screen. So, yeah. So this is the summary of what we've been telling. We are currently really happy with Flink. We really believe in this streaming data platform that we have. We actually want to, we have big ambitions. We want to push ING to the next level, away from batch processing into a real-time bank with a lot of predictive analytics, etc. in that. Because the reason for that is, of course, we want to be there for the customer. We want customers to like us. We want to be a love brand, as you call it. So, and that's the way that the bank is thinking. Okay, we can attract more customers, and we can attain the customers that we already have. For us, last year we were still experimenting a bit. We're now in the phase of that we have a platform running, we are in production, we have 2 use cases running in production, and the next year we'll bring a lot more, I think, and a lot more use cases, a lot more teams working on this, a lot more engineers working on the technology. So hopefully next year we'll have a big grand story again to tell with a lot of success in it. And that was it. Thank you.
Thank you. Questions?
Thanks for the talk and sharing all the nice use cases. I would like to come back on the first one with the when you withdraw money in the ATM. When you arrive in Berlin, so let's say this case happened, do you manage to block this transaction, or would be the next transaction that is blocked?
Yes, we block the transaction.
Okay.
We have the data here. We have actually that's what the performance requirements that we have come in to transfer money from one place to another takes about a second. That's more or less. Within that second, we have to make a decision. So we really have to get the data fast, process it fast, analyze it, and our performance requirements are 100 milliseconds for that. And so after that 100 milliseconds, we should make a decision: this transaction is okay or not.
Okay, cool. Thanks.
Hi, thank you for your talk. Really interesting. I was wondering how you handle evolving data or concept drift. Like, do you just train the model really frequently, or you don't see that much evolvement, like much change in the data?
Yes, so far is that we retrain the model not so often yet, but we want to do it actually, because it's still now a manual process. So we have data scientists working on the models and gathering the data and retraining them. That takes a while. That takes more than a day. So what I also explained previously, we actually want to, one of the next steps, it's on a backlog, right, is to incorporate a continuous feedback loop to really make that possible. But there's a few problems with that. Technically, it's not possible yet, and also the models change also in their setup, right? So we might now switch from a logistic regression model to something else entirely, and that means that you have to do this kind of changes manually, actually.
Okay. Yeah. So you're working on it?
Not yet, but we will be working on it.
Thank you.
Thanks.
Thank you. Some of the features you are developing are really have really an added value for the customers, some for the bank, so we can make more profits. But how do you prioritize your features? Do you classify your features to say this one has an added value for both, only for the customer, only for the bank?
It depends per use case. So in the end, we are going for a long-term relationship. We want to earn primary relationships. So it means actually that sometimes we will lose some money because we're advising the customer to take some money out of his savings account, but we think it's beneficial in the longer term that he will be happier with us as a bank, will, for example, use more products from us.
Okay, thank you.
Any more questions? Where? Ah, okay.
Hey, I have two questions actually. First one is this step after the road to relevant. You showed there is this DSL that someone can describe the model, the things they want to like predict. And my question is, if I understand correctly, there is like a separate stream of configuration that comes to this job, and then based on the events in this stream, I could say meta job reconfigures itself. So basically my question is, do you have something like big loop over the like scripts that evaluates the scripts, or do you like create jobs dynamically based on the configuration events? This is my first question. And second one is you told that you done some performance like research, if the Flink is the correct choice. are these like research published anywhere, like in some blog or some presentation?
Okay. First question is, no, we don't truly reconfigure the job, because that's actually the power of standardizing things. You have one job, which with a set of fixed operations, and we always know the same execution path. We know the execution path of that Flink job. So we're not going to reconfigure that. We're only going to reconfigure the true behavior. So in that case, what you suggested first, there's kind of a loop, which is basically evaluating the contents of the control stream once the events are coming in. Yeah, does that answer your question? Yeah. Second one is, we have not published the results in detail, other than putting on some slides like this. It might be possible, but I don't think that's too relevant. If you want to know more, then we can show you a little bit of maybe the code that we have, or the results for that. Yeah. Okay. Thanks.
Great. Thank you very much.
Okay. Thank you.